If you break your arm, an X-ray shows the fracture. It's
Right.
binary.
Right.
You can point to the jagged white line on the film and, well, know exactly what's wrong. And we expect that kind of precision from medical diagnostics because it is quite literally a matter of life and death.
Exactly.
But we rarely expect that kind of precision from drywall.
Yeah, you really don't.
Yet, looking at the stack of sources for you today, you realize that for the military, the placement of a colored cable or like the exact angle of an interior wall is just as critical as that X-ray. So welcome to this deep dive.
Glad to be here.
Today, our mission is to uncover the hidden logic of how the U.S. Army designs its brains.
Right. Specifically, their command and control facilities and major headquarters.
Exactly. We have a highly detailed 50-plus page architectural manual straight from the U.S. Army Corps of Engineers. It is called UFC 41403. And, okay, let's unpack this, because getting a peek behind the curtain of top-secret military design is, it's fascinating.
It really is.
But reading an architectural code manual sounds pretty dry until you realize what is actually at stake here.
Well, the stakes are, quite frankly, operational survival and information dominance.
Yeah.
It's crucial to approach this document not as a guide to just, pouring concrete and erecting steel beams.
Right.
It's a blueprint for a weapons system. The building itself is treated as an active participant in national security.
Which is wild, because I totally expected a manual on military headquarters to be entirely focused on, like, deep subterranean concrete bunkers.
Oh, sure.
Something straight out of the Cold War. But the baseline philosophy stated in the first few pages is completely counterintuitive.
It really is.
They explicitly want these facilities to function like a civilian corporate office or municipal administration building, combined with an emergency operations center.
Yeah, and that represents a massive shift in military thinking. The threat model has evolved. While physical security is always a factor, the primary battle space for a command center today is informational. So they need an agile vessel for technology.
Okay, that makes sense.
And the manual details how these spaces must drastically scale. You might have a division headquarters commanded by a major general, which is highly deployable. Then you step up to a corps headquarters. And at the top end, you have numbered armies. These function as massive regional hubs housing around 1,300 personnel.
Wait, 1,300 people?
Yeah, including civilian augmentations.
In a facility that is supposed to be somewhat deployable, or at least flexible? That is the size of a mid-tier tech company.
It really is.
It honestly reminds me of how major Silicon Valley tech companies build their campuses to foster collaboration. Except, instead of launching a new food delivery app, these people are launching a joint task force.
That's a great way to put it. And if we connect this to the bigger picture, the military is prioritizing long-term adaptability over brute force fortification. The manual specifies a 25-year useful design life before major renovations and a 50-year overall building replacement life. They are creating flexible, long-lasting hubs for human collaboration.
And there's a fascinating financial contradiction built into that longevity, too.
Oh, definitely.
Like, the Army wants to build the physical shell of these buildings fast and economically, adhering only to the minimum structural code requirements.
Yep.
They deliberately save the real budget for the high-tech interior finishes and the complex electronic systems.
Because the shell is just a container. The value and really the vulnerability lies in the human and digital flow inside.
Okay, right.
That is why the physical layout is absolutely obsessed with controlling who goes where. They use what they call an onion approach.
The onion.
The manual mandates 4 distinct security zones to aggregate spaces based on the sensitivity of the operational activities.
Let's talk about peeling that onion, because moving through this corporate-style building sounds like navigating a literal fortress.
It is.
You have Zone 1 is the outermost layer, limited access, mostly for support staff, public affairs, the chaplain, and, the main lobby.
Right.
Then Zone 2, which is controlled access for operational security, housing intelligence, and movement tracking. But Zone 3 is where the architecture really gets extreme.
Yeah, Zone 3 is the restricted access area. It's the inner sanctum. It's built to a standard that allows for the open storage of classified material.
Up to the top secret level, right.
Exactly.
And here's where it gets really interesting for anyone who watches spy movies. Usually picture classified documents locked in briefcases, handcuffed to some courier's wrist.
Oh, right. Or secured inside a massive steel vault.
Exactly. But the manual implies that in Zone 3, The entire room is the safe. Like
Yeah.
documents and data can literally be left out on desks or displayed on massive screens.
Because everyone who makes it through the physical and procedural barriers into Zone 3 is completely cleared. But to achieve that level of trust in the space itself, well, the physical security requirements to build that zone are just staggering. It's a total synthesis of physical barriers, electronic controls, and procedural security.
I was reading the section on the mailroom, which sits on the perimeter of these secure zones, and I just assumed it was about having metal detectors or X-ray machines for packages.
Oh, no. It's way more than that.
Right. The structural requirements for the walls are intense.
Yeah, the distribution or message center cannot just use standard commercial drywall.
Yeah.
The manual requires expanded steel fabric like a heavy metal mesh to be installed inside the drywall and the ceiling.
That's crazy.
The goal is to physically prevent someone from using tools or blunt force to smash through the wall from an unclassified corridor into the secure space.
And what if they try to go through the door instead of the wall? The manual mentions these double-cylinder locks featuring mushroom or spool-type drive pins.
Yes.
I know a standard lock has pins that align when you insert a key, but what is a spool pin doing differently?
So, if someone attempts to pick a standard lock, they apply rotational tension to the cylinder and use a tool to push the internal pins up to a shear line.
Right, like you see in the movies.
Exactly. And once all pins clear that line, the lock turns. But a spool or mushroom pin is shaped exactly like it sounds. It has a narrow middle and wider ends.
Oh, okay.
If a lock picker applies tension without the exact key, that narrow notch catches on the edge of the internal cylinder. The lock physically binds up and freezes.
Oh, wow.
It turns a quick, silent entry into a prolonged, frustrating, and likely noisy failure.
It forces the attacker to spend more time, increasing the chance of getting caught.
Precisely.
And to keep outside vendors completely separate from all of this, there's a specialized Zone 4. It's this isolated area built specifically for foreign national staff or high-stakes procurement negotiations.
Yeah, it keeps the core of the onion intact while allowing the necessary unclassified or foreign business to occur on-site.
So, assuming we have the clearance, we clear the lobby,
Yeah.
we bypass the steel-reinforced mailroom, and we step deep inside Zone 3 into the two most critical rooms in the entire facility.
The Operations Center and the Sensitive Compartmented Information Facility.
Right, the SEIF.
Yeah.
Let's start with the Operations Center, the OC.
The OC is designed to process massive amounts of data collaboratively. The manual outlines a space built around a massive wall of knowledge.
Sounds intense.
It's a huge array of audiovisual displays, and the room must be 2 stories high to accommodate the necessary sightlines.
Right, and at the back of that two-story room, they require an elevated balcony that has to be at least 15 feet deep. So observers, like visiting generals or allied commanders, can stand up there and watch the operation unfold without physically bumping into the staff working on the floor.
Exactly.
It sounds functionally identical to a NASA launch control room, but there's an architectural detail for the Operations Center that completely stopped me in my tracks.
The non-parallel walls.
Yes. The document recommends building it with non-parallel walls. Deliberately building crooked walls sounds like an architectural nightmare.
Oh, it is for the builders.
Think about the wasted square footage and the construction headaches. Is diffusing sound really worth all that trouble just for acoustics?
Well, what's fascinating here is that architects usually abhor dead space, but military planners abhor cognitive overload even more.
Okay, that makes sense.
When walls are perfectly parallel, sound waves bounce back and forth directly between them. This creates standing waves and amplifies the overall noise level in the room.
Oh, I see.
By angling the walls, you diffuse those sound waves. They scatter instead of echoing.
Imagine 100 people in a high-stress, life-or-death situation. Everyone is talking on headsets, shouting updates across the floor. If the room architecture naturally amplifies that noise, you destroy the team's ability to think clearly.
The architecture is quite literally engineered to keep the human brain calm. The manual goes deep into strict sound transmission class or STC ratings. For context, a private office in a standard commercial building might require an STC of 45. You can hear muffled voices through the wall, but you cannot make out specific words.
Okay.
But for the Operations Center and the SEIF, they demand an STC of 50 or better.
And the SEIF requires extreme isolation beyond just acoustics.
Yeah.
Like, it is the absolute highest security area for top secret and sensitive compartmented information.
Yes, it is.
The manual states absolutely no operable windows are allowed.
None. And it requires continuous radio frequency or RF shielding,
Right.
you are essentially building a Faraday cage. You're lining the room with conductive materials like copper or specialized metallic foils.
Just to prevent electronic signals from leaking out.
Or being beamed in by hostile intelligence.
Even the air vents are treated as vulnerabilities. Like, you can have a room wrapped in copper and steel, but the people inside still need to breathe.
Sure.
The manual mandates special HVAC duct, baffling, so that an adversary couldn't theoretically stick a microphone down an air shaft and listen to the conversations inside.
Yeah. The building relies entirely on its unseen infrastructure to maintain that secure bubble. To make rooms like the operations center and the SEF function, you have to engineer the nervous system and the respiratory system of the building to the exact same security standards as the concrete walls.
Okay, the nervous system being the immense amount of cabling.
Right.
The manual is incredibly strict about color-coded cable tray pathways running under the raised floors and through the ceilings. It specifies black trays for unclassified networks, red trays for secret and top secret, and yellow trays for TSSCI, the absolute highest level.
And this separation is mandated by Tempest standards.
Tempest.
Yeah, Tempest is a code name for the study of how electronic equipment emits tiny electromagnetic signals. Any electrical wire carrying data generates a faint electromagnetic field.
Okay.
If you run a top-secret copper wire right next to an unclassified wire, that electromagnetic field can actually induce a faint copy of the classified signal into the unclassified wire.
Wait, really?
Yes. An enemy tapping the unclassified network could reconstruct the top-secret data without ever breaching the secure network.
That is terrifying. Just the physical proximity of two wires can cause data to bleed across the gap.
Exactly.
And if a classified cable absolutely has to run through an unclassified area, say it has to cross through public zone 1 hallway to reach another secure room, it requires a protected distribution system, or PDS.
Right. The PDS is the physical manifestation of data security. It often involves pressurized piping with alarm sensors.
Pressurized piping.
Yes. Or clear acrylic tubes that guards must physically, visually inspect on patrol to ensure no one has drilled into the conduit to splice a wire.
Wow. Then we get to the respiratory system of the building, the HVAC and the power. The equipment load in these headquarters is massive.
Yeah.
The network operations center and the server rooms must be kept at a precise 72 degrees Fahrenheit and 45% relative humidity.
And the precision of that humidity level is vital.
Why is that?
If the humidity drops too low, the dry air increases the risk of static electricity buildup, which can arc and fry a critical server.
Oh, geez.
But if it gets too high, you risk condensation forming on the motherboards, causing short circuits.
And these servers are running the battlefield networks. If they overheat or short out, the entire command structure goes blind.
Completely.
That is why the manual dictates 100% dedicated redundancy. There must be a total backup cooling and power system that automatically switches over if the primary fails.
Heat and power loss are treated with the exact same severity as a physical kinetic attack on the building.
Wait, so the air conditioning and the backup batteries are literally a matter of national security?
You absolutely are.
Speaking of power, the backup battery details were wild. The manual mandates that the uninterruptible power source, the UPS systems, require specialized explosion-proof exhaust systems in their battery room.
Yes, they do.
These massive lead-acid battery banks literally off-gas hydrogen as they charge. They have to vent highly explosive hydrogen gas just to keep the facility prepared for a blackout.
It is a stark reminder of the massive physical energy required to run a digital war.
Seriously.
The facility has to manage its own highly volatile industrial hazards internally.
And the power goes towards some incredibly nuanced operational requirements, like the lighting in the video teleconferencing rooms, for example.
Oh, that's a great detail. In rooms designed for VTC, the lighting fixtures need special dimming ballasts and diffusers.
Right.
But the goal isn't just to set a mood. The lighting has to sync specifically with the light sensitivity and dynamic range of the video cameras being used.
Because if the lights wash out the participants' faces with glare, the generals look like ghosts on the video feed.
Exactly.
In a high-stakes negotiation or a tense briefing, reading subtle facial expressions is critical human intelligence. The architecture literally accommodates the camera sensor to ensure flawless human communication across the globe.
It's all connected. So we have explored the deeply buried brain of the facility.
Yeah.
You know, the acoustic walls, the colored cables, the hydrogen venting batteries.
Yeah.
But this building does not exist in a vacuum. It has to directly interface with the kinetic battlefield outside.
That transition from the static fortress to the mobile force is fascinating. Let's look at the site layout outside the building.
Sure.
The front of the building has this ceremonial welcoming drive. The manual specifically notes there must be exactly 15 VIP parking spaces.
Very specific.
Right. The military runs on rank and protocol, so ensuring key visiting commanders have a designated secure approach makes sense. But the back of the building is a highly secured tactical staging area.
Yes.
Also, there are 0 antennas allowed in the roof of the headquarters itself. Why not just put them on top of the building like a normal commercial skyscraper?
Because antennas emit and receive massive amounts of RF energy. They make a building a very easy target for enemy signals intelligence to geolocate. If the antennas are on the roof, an enemy missile knows exactly where the generals are sitting.
That's a huge problem.
It is. Instead, the manual requires a separate, securely fenced antenna farm located far away from the main building, connected back to the facility via deeply buried underground fiber optics.
That brings us to a highly unique architectural feature called the TSVA, or the Tactical SCI Vehicle Area.
Right.
It is a secure parking lot immediately adjacent to the SCIS, specifically sized with reinforced concrete to handle the immense weight of MRAP's mine-resistant ambush-protected vehicles. To me, this looks like a high-tech drive-through window for armored trucks. So what does this all mean?
Well, functionally, that is exactly what it is. This raises an important question that military planners have wrestled with for decades. How do you balance rapid mobility with absolute digital security?
Right, because historically, there has always been a severe vulnerability gap. You have your highly secure, static headquarters and your highly mobile units in the field.
Exactly. Transferring data between the two was the weak link.
Someone had to literally carry a hard drive across the gap, stepping outside the secure perimeter.
The TSVA eliminates that vulnerability entirely. An armored truck can roll up from a war zone, pull into the secure fenced area, and plug a weatherproof tactical interface box directly into the building's underground fiber optic network.
That's incredible.
The vehicle can instantly sync with the top secret network without a single person having to step outside. The vehicle temporarily becomes a physical extension of the SCIF.
It is a brilliant physical plug for a digital problem. Every single detail in this manual, from the VIP parking to the armored drive-through, is carefully calculated to reduce friction in command and control.
It really is. Let's summarize the journey we just took through USC 41403. We started with the philosophy, the idea that the Army is building a scalable combination of a civilian corporate office and an emergency operations center designed to adapt over 50 years.
We moved through the onion of security, those 4 distinct zones, culminating in the open storage requirements of Zone 3, where the physical fortifications of spaces like the mailroom use steel mesh and spool pin locks to buy time against an attack.
Then we stepped into the Operations Center and the SCIF, analyzing how non-parallel walls and STC-50 ratings create an acoustically diffused environment to prevent cognitive overload,
Right.
while Faraday cages block electronic eavesdropping.
We examined the invisible systems, too. The Tempest-compliant colored cables preventing electromagnetic bleed, the redundant HVAC systems fighting static and condensation at exactly 72 degrees, and the hazard mitigation for the hydrogen venting batteries.
And finally, we walked outside to the tactical SCI vehicle area, the ultimate secure drive-through that seamlessly connects the kinetic armored battlefield directly into the static top-secret network. When it comes to information dominance, architecture truly is destiny.
We started this deep dive talking about the precision of an X-ray. We usually think of buildings as just passive containers where we happen to sit and do our work. But this manual proves that a building can be an active, engineered participant in how well we think, how clearly we communicate, and how securely we operate.
Form follows function at the highest possible stakes.
Which leaves me with a final thought for you, the listener, to mull over. We have just spent all this time detailing how the U.S. Army spends millions of dollars, writes massive manuals, and expends staggering engineering effort to meticulously design spaces that control the flow of information, mitigate noise, and prevent intellectual bleeding between teams.
Yep.
They literally build crooked walls so people can focus under pressure.
It is a massive financial investment specifically targeted at human cognitive performance.
So what does that say about the totally unstructured, chaotic, open-plan offices that so many of us force ourselves to work in every single day?
That's a great question.
If the military considers acoustic diffusion and visual sightlines to be a matter of operational survival, could our own workspaces be silently sabotaging our ability to think? Thank you for joining us on this deep dive into the hidden architecture of command. Until next time.